Good morning, integrated 2 and extended 2. This is day 2 of the probability, short probability unit. And today's lesson will be about the addition rule, or, or we call it the OR problems. So we'll start off just looking at a situation that we'll eventually find the answer to. An experiment, a single-sided die is rolled. What is the probability of rolling a 2 or a 5? So when we look at this problem, we start off looking at the possibilities. So the number rolled can be a 2. The number rolled could be a 5. These two events are what we call mutually exclusive, which means exclusive, they cannot occur at the same time. So I can't roll a die and get a 2 and a 5 at the exact same time. So we called those mutually exclusive. So how do we find the probabilities of these mutually exclusive events? And what we need is a rule. The thing about today's lessons and tomorrow's lesson is that there are some rules, formulas, if you want to call them that, but they are rules that if you follow them for the given situation, for example, like this problem, there's an OR in the problem up at the top, then there is a rule for that, and that's what we're going to use for these problems today. So the addition rule number 1. When two events, A and B, are mutually exclusive, that means they cannot occur at the same time, the probability of A or B will occur is the sum of those probabilities. So in notation, we would write the P for the probability, A or B equals probability of A plus the probability of B. So if we go back to our dice problem, we had the problem where we're going to roll it to a single-sided die and answer the question, what is the probability of rolling a 2 or a 5? From yesterday's lesson, you had you were finding simple probabilities like what's the probability of rolling a 2? Well, the probability of rolling a 2 is 1/6 because there's 6 sides and there's 1 2. Probability of rolling a 5 is 1/6 because there's 1 5 out of the total of 6. And then if we take those and add them together, like the rule says, the probability of a 2 or a 5 equals 1/6 plus 1/6, which equals 2/6, or reduced to 1/3. That is called the addition rule, and you just add the two probabilities together. There's a theme today. When you see the OR, you're going to be adding some probabilities. Now, we'll make a slight change to that in a little bit, but for the most part, or from these ones at the beginning, you will be adding those two probabilities together. So here's a second experiment. A spinner has 4 equal sectors, yellow, blue, green, and red. What is the probability of landing on red or blue after the spinning, or after spinning the spinner? So we just first know what the probability of red and the probability of blue are. Now, they didn't give us any numbers, but we have 4 sections that make up the whole, so you need to think about what their probabilities are. There's 4 sections up there. They're all equally likely, so the probability of red would be 1/4, and the probability of blue would be 1/4. And since we want the probability of red or blue, the addition rule said to add those together, and you would add 1/4 plus 1/4 get you 2/4 or 1/2. Experiment 3, or example 3. So we have a jar that contains 1 red, 3 green, 2 blue, 4 yellow marbles. If a single marble is chosen from the jar, what is the probability that it's yellow or green? So we'd have to know what the probability of yellow is. So the probability of yellow, there's 4 yellows. I got to know how many there are. So 1 plus 3 is 4, plus 2 is 6, plus 4 is 10. So there's a total of 10. So the probability of yellow is 4/10. There's 3 green, so the probability of green is 3/10. And since we're doing, again, the OR problem, okay, so probability of yellow or green, we're going to add those two probabilities together. Again, they're mutually exclusive. You can't be yellow and green at the same time in the marbles that we have. So the key here is that they're mutually exclusive. So probability of yellow or green, 4/10 plus 3/10 equals 7/10. So sometimes you'll deal with situations where you can be something, two things at the same time. And we're going to look at that next. So in each of those 3 prior, keep this in mind that those events were mutually exclusive. The 2 events that we had on either side of the OR could not happen at the same time. So what happens when we have non-mutually exclusive events? So let's look at an example here. So this deals with a deck of cards. So just a refresher, or if you're not sure about a deck of cards, there are 4 suits. Hearts, diamonds are red. Clubs and spades are black cards. You have 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and ace. There's 13 of each of the suits, making a total of 52 cards. So if we take a single, randomly choose a card from a single deck of 52, what is the probability of choosing a king or a club? So if we followed the rule like we did last time, we would just find their probabilities. Well, there's 4 kings out of 52, and there's 13 club cards out of 52. And if I add those together, I would get 17 out of 52. But the problem is that there is a king of clubs. So which one did you count it in? Did you count it as a king, or did you count it as a club? If we use the 4 and the 13, we actually count it twice. So if I just add those together, I end up with 1 too many. I doubled up. We double up in this situation. The king of clubs falls in both categories. So it's not mutually, these events are not mutually exclusive. So we have to take that one away. So it would look something like this. We had the 4 out of 52 for the king, the 13 out of 52 for the club, and then this is one of those, one extra king of clubs, and we have to take it away in order to keep from doubling up on that. So we get a total of 4 plus 13 is 17, minus 1 is 16. Notice I did not reduce any of these fractions with the 52s until I got down to the end to get that answer. So when they're not mutually exclusive, the rule changes slightly. Okay, so non-mutually. So what was the difference? We counted it twice. And that's the thing to remember, is that you're going to have to take something away. When two events can occur at the same time, you're going to have some overlap. And we have to subtract that overlap out. So the formula looks something like this. So we have 2 events that are non-mutually exclusive. Probability of A or B would be the probability of A plus the probability of B minus the probability of A and B. So on that last problem, the 1 out of 52 was the king of clubs. There's 1 king of clubs out of all 52 cards, and that's why we subtracted the 1 off. So this, in the rule, the probability of A and B refers to that overlap. So let's apply the rule to some experiments or examples. So we've got a math class. There's 30 students, 17 boys, 13 girls. On a unit test, 4 boys and 5 girls made an A. If a student is chosen at random from the class, what's the probability of choosing a girl or an A student? Now, a girl and an A student are not mutually exclusive because you have girls that got A's and you had girls. So here we have that overlapping. in this situation. So we're going to have to think about how many how many of those are. So we'll start off. I'm going to write the formula out with words in it. And a lot of times it makes it helpful to write it out in words. So then, circling is not very good, folks. Sorry about that. But if you write it out in words, sometimes it helps you focus on what you need to find. So now we're going to find the probability of a girl. Well, there's 13 girls, so that's 13 out of 30. So 13 out of 30 will be the girl. Probability of A, well, there's 9 A's. There's 4 boys and 5 girls. So this is just the probability of getting an A. So that's 9 out of 30. And the probability of a girl in A, well, that's 5 girls out of 30. So if I put all those numbers in the formula, this is what it looks like. There's the 13 out of 30. That's the number of girls. 9 out of 30, that's the number of total A's. And then minus 5 out of 30, because we already counted them, equals 17 out of 30. Again, writing it out in words or symbols that represent maybe not just A's and B's. The A in this situation was the letter grade A. But writing it out in words sometimes can make that problem a little bit easier to know what to focus on. So I encourage you to write out that formula and put those numbers in after you have the words. As a teacher, it really does help when we're assessing or looking at trying to give you feedback as to whether, where was the mistake? Did they make a mistake in the formula? Well, if you had the formula right, did you just find your simple probabilities incorrectly? So any evidence there that you can give can be beneficial to us. So these, you had to find the probabilities in this example. The next example, they're just given to you. They're given to you as decimals. And probabilities can be fractions, decimals, percents. So the next example will involve using some decimals. So on New Year's Eve, the probability of a person having a car accident is 9%. The probability of the person driving while intoxicated was 0.32 or 32%. The probability of a person having a car accident while intoxicated is 0.15. So what is the probability of a person driving while intoxicated or having a car accident? So if you wrote out the problem in the formula in words, not A's and B's, but in words, it would look something like this. So there's our probability of intoxicated or accident. That's what we want to find. So the formula says we take the probability of the first one, intoxicated, plus the probability of accident, minus the and of those two things. So when I come up here, I can see, okay, there's the probability of an accident. That's 9%. So this is going to be 9% right here. That's my 9%. Probability of accident is 32%. And this, and there's only one other number, so that's going to have to go here. But when you look at this, it doesn't say the probability of a person having a car accident and intoxicated, but it does imply it because it says accident while intoxicated. Those two things are occurring at the same time. And that's what the 0.15 is. So when you plug your numbers in, we don't have to find any fractions. We just take the decimals, we add it up, and we see there's a 26% chance of that occurring. So the last 3 pages will be examples or problems that you'll answer. These will be answered in the Edpuzzle. So there's the first one. And there's practice 2. And practice 3. And finally, practice 4. Your assignment will be about 10 questions, I believe. It's a Google Doc, or open up. I'm sorry, you'll open it in Kami and answer your questions. And good luck.